to talk about, well, as it says, how to query a stream. There's a lot happening in the way, not just in data infrastructure. There's always a lot happening in data infrastructure, right? Something new. There's a lot happening in the way we build applications and in the fundamental architectural paradigm that we use to build business software. That's in transition right now. And a lot of what I've been thinking about in the last few years is that transition, trying to make sense of it, trying to understand it from a historical perspective. I'll talk about a little bit of history today. And try to understand where we are and where things are going in the middle of that transition. And I take a fairly data-centric perspective. Like my bio says, I work for a company called StarTree, and we make a database that kind of lives in this world. But there's a lot more to the story than that. And I want to talk about those things. I want to, like I said, explore some history and then look at what our options are for querying a stream and then see where that's going to send us. And I'd love to have some time for questions. So if you think of a question, if you're like me, you have to write it down or put it in your notes app or something like that. Maybe you're not like that. Maybe you'll still remember it. But hold on to it, and we'll take those at the end. By the way, I obviously decided to use AI for the slides. I thought, let's just see what this is like. These are all in the style of an Italian Renaissance painter named Caravaggio. He happens to be my wife's favorite painter. She has a favorite painter, which is interesting in itself. But there you go, Caravaggio on querying a stream. So remember, not too long ago, a simpler time that we lived in. If you were building software for a business, I mean, there's lots of kinds of software, right? But business software. If you're building software for a business, you had a database kind of at the center of your world. That database held a snapshot of everything that was true. Whatever the state of your world is, it's just there in the database. You wrote a program to make changes to that database and expose some kind of nice interface to the world. I mean, it's really built around this database, but you're kind of creating abstractions that let people do CRUD operations on the things in the database in some nice way that maybe doesn't feel like CRUD, but really is. And it always feels depressing when you summarize all of business software. You're like that. Wow, yeah, okay. I get a little piece of JSON and I write it to the database, and then I read something from the database and I turn it into JSON and I send it on. Like, okay, that's my life. Don't get depressed. It's honest work. Anyway, sometimes representing the state of the world in the database was hard. Sometimes user interfaces were hard, and it's hard to understand business processes and all of that, right? Business logic is weird. It's not like software was ever easy, but we knew how to build monoliths. And some of us had the opportunity to get good at that, right? And in a sense, we can look back on that as simpler times. It was nice. And we also needed to be able to get some idea, some insights into what has happened. So what did we do? Well, we decided to extract changes from the database every day, squish them around into another form, and put them into a separate database so we could run reports against that database. That's the data warehouse, okay? And data warehouses, that term goes back long before we said monolith, but it really came into its own as a term and a technology and a discipline and all that stuff. If you look at when were the first books with data warehouse in the title published, that was kind of in the 90s, when we didn't say monolith back then. We said client server. It was the brilliant new idea that wild-eyed, crazy conference speakers were saying was going to, cure poverty back then in the 90s. And the data warehouse was a part of that world. Okay, so we took changes out of the transactional database, mushed them into another form, stuck them in the analytics database. We were able to draw in lots of different sources. You had to optimize the schema. You could pre-compute aggregations to make things go fast. It was a wonderful world. We had the monolith, or the client-server application, and we had the data warehouse. That was great. Now, the internet happened, and client-server and the data warehouse didn't notice right away. I mean, all of the people who were building the first web applications were people who had just recently started 5 or 10 years earlier building client-server applications. They're like, okay, I'm taking that tool set and I'm going to make websites with the same architecture. And likewise, if you had a data warehouse, that's how you do it. So we take the data, we move it to the data warehouse. And that worked for a little bit until the internet really, got comfortable and more people globally have it. And then in the late 2000s, kind of around 2008, 2010, 2012, smartphones began to penetrate in a way that really broke that old paradigm, all right? Because now we're in this world where, and this is the world that you and I live in now, a lot of our commercial and social lives are mediated through a device. Stuff that, you used to go to your bank and make a deposit, or go to a store and buy a thing, or I don't know, go to a club and meet people, whatever it is you're into, right? You would do that in the physical world. Now there's software to do that. You just do it on your phone. It's on a mobile device. So all of that creates data, and those old paradigms could not survive the kind of data that mobile and the internet together created. So client-server as an architecture was starting to get a little tired. And the data warehouse, that old school data warehouse developed in the 90s that was a transformative technology then, didn't work anymore. It was starting to break. That gave rise to, of course, big data. Hadoop happened. Hadoop was very popular for about 25 minutes, and then it gave rise to a bunch of other technologies that we'll explore some of their stories today. These days, Hadoop is really a historical footnote. We kind of say data lake. That describes what has taken the place of the data warehouse in various complex forms, and we'll cover data lakes. What happened to applications? Well, we started breaking monoliths into pieces, shown here as these giant brass globes. It's kind of like a Italian Renaissance steampunk look. I personally wish software looked like that, but it doesn't. Anyway, we started breaking them into pieces, and initially, I think around 2010, 2011, the first attempts at microservices were just bad. It was not a good thing. They were very ugly, and we kind of felt around in the darkness, which is what we're always doing when we're inventing things, right? We're always just kind of blindly looking around for something that feels like it might work. Kafka showed up, and eventually people started connecting their microservices through topics and having them exchange events, and that started to feel like maybe that was going to work. So at the beginning, I said we're in the middle of this disruption in application architecture. That's the disruption that I mean. And this talk isn't primarily about that disruption, but that is the thing that's driving what is making life difficult and exciting for us right now. Because instead of a database and a big program around it, and that's great, that didn't work. So now we have a bunch of little programs connected by event logs and various other databases all over the world. It's a completely different way of writing software. We are now in the middle of understanding how to do it. So, Kafka happened. It's been a great thing. But before that, moving data around between these services, people would write sort of one-off jobs to pipeline data from one place to another. They were brittle. It broke a lot. It just didn't work until Kafka came along, and we said, okay, now here's this standard way for all of us to agree there's this fundamental data abstraction, the log, and it kind of underlies a lot of what we do. And we're not all of us are living that life in a pure form right now, but we're definitely migrating towards that. Okay, logs are the fundamental data abstraction underneath our data. It's easier to extend systems by building new services. It's easier to read about logs of immutable data. All this is pretty good. The problem is, logs are great for a lot of things, but they are very difficult to query. In fact, you can't. That's not what a log is. There's one thing you can do with a log, and that is ask it for the next thing. That's it. That's the interface. I mean, you can put things into it on the end, right? And you can maybe seek to some position, but then it's give me the next one. That's how a log works. We need more than that, all right? They exist, and Kafka has kind of risen to prominence for a very good reason, but we need to do more. And I want to, as we focus on this, how do you query a stream problem, and this sort of combination of, if you could see visually here, you know, the data warehouse and streams, how do these things come together? There's going to be a couple different senses in which we want to query streams. Just like traditionally, when we think about databases, we think about OLTP databases and OLAP databases. There's the transactional world and the analytical world. I think those same things really apply to querying streams too. Those concepts are somewhat fundamental. And even if you take the database away and you just look at the underlying log, those concepts kind of pop up from the corner and they're over there winking at you. You know, OLAP and OLTP just emerge. They're not accidental things. So, as a reminder, when I was talking about the architecture we're leaving behind, the database at the center of the world, that was a transactional database. It was optimized for transactions. Things change out in the world. You want to change those things. You want to reflect those changes in the database. And I think a key, if we went around the room and I said, this would be a fun poll to do sometime, you know, short answers. How would you define a transactional database and how would you define an analytical database? You know, there'd be interesting answers because there's not just one. I'm going to give you this. A transactional database is typically interested in a thing, right? There is an entity. The thing in the where clause is often, you know, where ID equals this number. I want to read it, I want to write it, I want to change it. So there's the one thing. An analytical database is usually interested in lots of things. So you're going to scan over some set of results. There's some number in there that you want to pull out of those and compute an aggregation over that number. Maybe you're grouping, you're filtering, like queries get sophisticated, but the general principle is analytical, this thing, transactional, this thing, analytical, these things. That's the distinction I want to make. And this comes up when we think about streams. So sometimes I've got a stream of entities and I might want to know what's the value of some key, right? Like my employee ID is 24601. What's my current address? I've moved a lot in the last 3 years. I keep having to update my address. I don't recommend it. But here I am. And I keep having to change my address. And I might go into that system and say, all right, what is my current address? That's a lookup. That's like the transactional kind of stream query. Or, of course, I might look over many events and the same thing, you know, compute some aggregation over some metric. So with that OLAP stream querying, you want that to happen in real time. Once you've moved data into logs and you've got this general sensibility in your system of events driving behavior, you're not going to want to wait to okay, here's this log, here's this, you know, Kafka topic of data. Let me run some batch process where I write a bunch of files in S3 and then put big jobs to run queries over. That just sort of, you can do it, right? But that's kind of shaped the wrong way. You might want analytics that happen right now. So now that we've moved to logs, we still have OLAP, we still have OLTP, and let's take a look at our options. How do you query a stream? Well, these ways. And I guess I could just say thank you for coming. This talk brought to you by. So the rest of the talk, I just want to walk through each one of these and explain the trade-offs. Does it function analytically? Does it function transactionally? Can it be both? And what life is all about in these spaces. So let's do it. All right, let's get started with Kafka Connect and a relational database. So remember our architecture. There are microservices. They're consuming work from topics. I get a message. It gives me work to do. I do the message. I do some computation. Maybe I consult some other data sources. I enrich that event. And I put it somewhere else into another topic. That's kind of the basic structure of my reactive microservice. And assuming that world, there's a topic that I need to be able to query the stuff in there. That's what we're doing here. And option one is I get Kafka Connect out, and I read all the events in that topic and write them into a relational database. Now that relational database, I have all of the power of that database. I can query what I want. It's a very well understood tool. So this is kind of a nice thing. And this is the structure. There's the Kafka cluster, with topics. And Connect, if you don't know Kafka, you don't know Connect well, Connect is really its own separate little distributed system. It's a cluster of Connect workers that are reading from topics and writing into a database. This is on the sync side. Connect can also source, but that's not in view today. Consult. There's a great website called Confluent Developer, developer.confluent.io. I helped make some of it back when I was there. And I think there's some good stuff on Kafka Connect if you're interested in more. Generally, you'd think of this as a good solution when the data is not too big, okay? Because you're putting it into a relational database, and you don't want to have to start to think about exotic methods of scaling that relational database. If you say, well, I think I have to shard now, that's a good sign that this is not for you. If it fits on one instance comfortably and performs well, this can be really nice because everybody knows how to query that database. Maybe you don't know how to run Connect, but it's not so bad. And this also really is the appropriate for the transactional side of things. Now, I could run analytical queries in that relational database, and you might find that for the size of data, the number of concurrent queries, the latency, SLA that you need to find, maybe that works okay, but probably if you're doing analytics and you've got this real-time system and you're operating at scale, that is going to not feel very good. But the transactional, I need to look up by a key, or maybe I need to index 2 different fields, and sometimes this key and sometimes that. Like, you've got all that. Just go for it. Do it. And so it's good on the transactional side of things. Also, as I have said, it's just familiar. Connect is not very rare. If you're using Kafka, there's a good chance there's Connect lying around somewhere. If you're not, it's not so hard to learn. And the database itself, which is the thing you're going to touch the most as an application developer, you just know how to use it. Pick the one you like. This world is changing as there's kind of a new crop of startups that are trying to take. It seems like it's always Postgres. Postgres has kind of won the API war. It's got to be Postgres wire compatible and Postgres SQL compatible, and it's all great except for the command line. I mean, come on, \T, really? But there are some startups in the space that are making interesting cloud-native, scalable Postgres-y things. There's one called Nile that's doing some interesting things in that space. So this could be a thing that gets easier to scale over time, and maybe these cloud Postgreses start growing some functionality that looks like Connect in a cloud-native way, but doesn't require you to run Connect. So I expect this space to evolve. I expect this to be a thing that people do, and it's a great way to do it. Some trade-offs, like I said, probably on the smaller end of the data spectrum, probably transactional, but there you go. Now, Kafka Streams. So Kafka Streams is a Java API that's a part of open source Apache Kafka. There's really 2 ways you can use Kafka Streams. It lives on the transactional and the analytic side of things, okay? So a Kafka Streams application is a Java application. You deploy it as just an independent application. You can deploy multiple instances, and it figures out how to scale by itself. It's got lots of built-in features, but it's reading from a Kafka topic. And on the transactional side of our problem of how to query a stream, it's going to ingest directly from a Kafka topic, and it contains an abstraction called a K-table. There are 2 fundamental abstractions in Kafka Streams, K-stream and K-table. K-stream is a very simple, lightweight abstraction over a topic that provides an API for doing things like filtering and grouping and converting into K-tables. So a K-table is kind of like if you took that topic and just rotated it. So now you've got basically a key value store, because the messages in that topic, it being Kafka, right, are themselves key value pairs. And so think of a K-table as just reading those in and sticking them into a hash table, the key and the value. So now I can do that key lookup that I've been talking about. It's brilliant. It's actually 1 line of code in Kafka Streams if I want to do that looking up. And that key value store is in memory. It is scalable, like I said, horizontally scalable over various nodes in ways that are outside of our scope. Again, you could find some good stuff online about Kafka Streams if you want to know. And this is a suitable way to query by the key of the topic. So if the topic doesn't have the key that you want to do the query by, you have to repartition, rekey the topic, basically make a new topic. And Kafka Streams will even do that for you under some circumstances, so maybe it's no big deal, but that's the limitation, that you get that one key. As many keys as you want, as many indexes as you want, as long as it's one. And scalable, already said that. To read these K-tables, there's this other API called interactive queries. And that's just another built-in part of Kafka Streams, but that's the way that you go and say, hey, there's this K-table I made, it's got this name, I want to go look up this key, and you interact with that API. It's, in my opinion, a little bumpy. It feels like you'd want kind of a one-liner, like you connect to the application, to the Kafka Streams application or something, and say, well, okay, the state store is called this. I want this key from that state store. And like, you don't know which node it's on. You're connecting to, say there's 4 nodes in the Kafka Streams application. It could be over here. You don't need to know that. You just want to know what the key is. If you look at code, example code for interactive queries, you have to kind of go back and forth with it a little bit. It feels like it should be wrapped a little bit more and be slightly more abstract, but it absolutely works and performs well. And this is a way that you can query a stream. And it looks like this. There, that's actually a 2-line. That doesn't include the interactive queries code, but that is creating a table out of a stream, and it's now a queryable stream. And if you're using Kafka, and if you're writing your code in Java or Kotlin, or maybe some bad decisions and you're going through a difficult time and you're using Scala, I'm here to talk to you if that's the case. Sorry, can't resist. Those jokes were funny 10 years ago. They're still a little bit funny now. Using a JVM language, you're using Kafka. It's probably appropriate to make an investment in Kafka Streams. And it's just a very simple way of making this happen. Okay, the analytical sense, because Kafka Streams works on both sides of this divide. It's not just make a table out of a stream, but it's this rich API, like I said, where you can filter, you can group, you can join, you can do sophisticated things with time windows. There's like 4 different kinds of time windows in Kafka Streams that you legitimately need animations to understand. Like, I dare you to try to understand them with a static picture. You can't. It's a complex API, and I mean that in a good way. Okay, so if you're doing analytical queries on streaming data, you're going to need to deal with time. It gives you all those tools, and you can do whatever stream processing computation you want. There's the kind of Kafka Streams high-level API, and if you're too cool for that, you could do Kafka Streams, just give me a message and access to the state store, and I'll handle everything. It lets you kind of move up and down the stream processing stack in a cool way. And not only can it make a K-table for querying, but it can also take the result of that analysis, the grouping, the aggregating, the whatever you're doing, and barf that out into a new stream, a new topic, which is kind of a different topic, as topic, right? Stream in, process, stream out is not where we are today. We're just stream in, read. That's what we're thinking about. But it's a feature. It does that. And as the same thing, queryable K-tables. Downside being that if you think of the queries you want to do on the stream, there's these read patterns, you have to build a separate Kafka Streams topology, but probably a separate Kafka Streams topology for each one of those. You might get away with a single topology that has a couple of different named state stores in there that you want to be able to query both of them, but you're probably going to write a separate Java program for every query that you want to do. That's pretty heavyweight. Now, it might be the thing that you want, it might be great, but if you're used to typing out some SQL and having that run, this is going to feel like a lot. Yeah, of course, interactive queries are the way. This is some code. It's, I know, pretty small from the back, and we're not walking through it, but I want you to kind of get your eyes around. This is word count in Kafka Streams. It's about how long it is. If you're brand new to stream processing, like I said, there are hard things to learn like time windows and late arriving data and edge cases of how failures work and how each of the stream processing solutions deals with those. You really can go deep, but the basic API is just not so bad. Next, the various streaming SQL solutions. There are a lot of these. You know, I said how there are some startups that are kind of trying to make sort of a cloud native Postgres kind of thing, like their own Postgres. Everybody wants to do streaming SQL. And there are a lot of these, and I want to call it out ahead of time, respectfully. It might sound like they're very similar to one another. So as I go through these, if it sounds like I'm repeating myself, that's not because of me. They are very similar. And in terms of deep dives, like if you had kind of like an hour-long talk on Materialize and Delta Stream and Rising Wave and KSQLDB and all these, like if you really went in depth to those, yes, you can find differences. They're not just copies of each other. And some of the differences are interesting, but at this survey level, they're going to seem very, very familiar. Now, what's missing from this list of streaming SQLs? If you know the space a little bit, if you're paying attention, you might be thinking, where's the squirrel? Where's Flink? Why isn't Flink in that list? Dang it, Flink is a streaming SQL, right? It is. I mean, it can be. That's kind of the way a lot of people use it. Flink is not, well, okay, Flink is, I wanted a cute picture of a squirrel. Flink is only in this talk to say, Flink is not in this talk. And the reason for that is the architecture of Flink, explained very simply, is for the streaming case, here's a source of unbounded streaming data, here's a job that does computation, here's a sink of unbounded streaming data. So in Kafka terms, consume from a topic, compute stuff, produce to a topic. Now in here, there's all kinds of stateful things that can happen, and so Flink does have a state store story and things that you'll have to know about that as an advanced Flink user, even a moderate Flink user. But Flink does not expose that state store. So you can never query Flink. You can use SQL to define stream processing, streaming computation to do, but it's always going to go to a topic. And so if Flink's a part of your life and you want to query the output, then you have all of the other options in the talk. You're still left with the problem of how to query a stream. So that little squirrel is fantastic, and it's a very important part of the world, but it's just not what we're doing today. So we'll leave him in his little cage, and I hope he's happy, and we'll see him some other time. All right, let's talk about Materialize. Materialize is a startup doing one of the streaming SQL solutions, and it really positions itself as a replacement data warehouse. So it's kind of saying, you know, your data sources are probably streaming, aren't they? So rather than writing them into Parquet files or Iceberg or Hootie or whatever you do, let's just put them into Materialize, the new streaming data warehouse. And it integrates with things you might expect, like Kafka. It'll consume from Postgres. It'll do change data capture from Postgres, transformations defined in DBT, and the center of the world, kind of a key abstraction in Materialize, is a materialized view. So you bring in this streaming data, you, with SQL, describe computations you want to happen, and you can create table-like things to view, and those are actually persisted in storage inside the Materialize system and queryable. So this is a way to query a stream. You can use Materialize to just get that job done, and it's wire compatible with Postgres because, well, that's just how we do these days. There's nothing about Materialize that keeps you from using it as a transactional stream querier. If you just want to do key lookups, that's completely fine. It positions itself as this data warehouse analytics solution. So if you go to the website, if you kind of look at materials on it, they're going to be talking about analytics type things, and that's probably the sweet spot, but it functions on both sides of the divide. Delta Stream. Delta Stream is founded by one of the original creators of KSQL, which was, we'll cover KSQL. KSQL is kind of Kafka's, sorry, whew, I'll have to edit that out of the video. Confluence streaming SQL, those are different things. Sorry, Apache Software Foundation, I didn't mean it. Yeah, so this is founded by a guy who sort of built one of the first streaming SQLs and said, hey, you know, we could make this cloud native and it would be way more cool. So that's really what this is. It's a cloud native streaming SQL. It's pretty advanced. It does a good job at keeping you from having to think about the cluster. You know, like how many nodes are there in the, like, why do you care? I thought this was the cloud, you know? Do that for me. And it also, if you're not yet familiar with BYOC, that's sort of a next generation way SaaS infrastructure companies are doing this. That's where, think of it like you give them your Amazon account and they'll poke a hole into that and go set up their data plane on your instances. And so if your company's got like a big, you know, enterprise agreement and you can consume a certain amount for a good price and everything, it just all happens for you. Your security people are happy. It's kind of a cool thing that I'm seeing more and more of. And then all the control plane and management and stuff is in their magic. Anyway, yep, it consumes from the regular sources, and you can define materialized views. Those are for querying and streaming pipelines. So you can do the stream in, stream out, and it's got materialized views. So again, this is one of the streaming SQL ways to query a stream. And Delta Stream describes itself as in both, on both sides of the fence. So streaming database, that's language they use. That means transactional. Streaming analytics, obviously, that means OLAP. So it's functioning on both sides. Rising Wave is another one. This, in their words, they are a distributed SQL streaming database. Again, if these are starting to sound familiar, they are very similar to one another. There is an open source version of this, and there is a fully managed server, or fully managed version of this. Fun thing about this is it is a clean room reimplementation of Flink in C++. So if you know Cassandra and ScyllaDB, it's that kind of thing. And there's another one. There's Cassandra and Scylla. There's Flink and Rising Wave. And there's another one that I'm blanking on right now. Anyway, this is a thing we do. Somebody writes some very successful piece of data infrastructure in Java. Somebody else says, your tail latency sucks. I don't like garbage collection. And I want to be able to do better single node performance. I'm going to rewrite this in Rust or something, in C++ or Rust or whatever. And that's what we've got here. Plus, it's not just a rewrite of Flink, but it adds queryable state stores. So that thing that I mentioned in Flink that it won't do, Rising Wave does. It makes those state stores queryable, basically. Typical ingest sources, persistent views is what they call them. And guess what? It's Postgres wire compatible. So in the future, all databases will be Postgres wire compatible for 15 minutes. Okay, KSQL DB. This is a Confluent thing. There is a community licensed version of it that you can run yourself, or you can use it in Confluent Cloud, and they call it a streaming database. It provides a stream and a table abstraction that are basically exactly like KStream and KTable. In fact, under the covers, they actually are KStream and KTable. So KSQL DB is kind of like a way of writing a Kafka Streams application with SQL. And that's an implementation detail. That's probably not a great way to message the product. Like Confluent's never going to call it that, but between us, that's what it is. And they've got this terminology that I have always found somewhat regrettable, but it gets at this difference between the transactional and analytical side of things, kind of, and that's push and pull queries. So a pull query, from the standpoint of the client, is where you go in and you get something. So if you've created a table because you want to do key lookups on some topic, then you can do a pull query from that ID. If you've done, Likewise, if you have created a table by grouping over something and running an aggregation in the analytical sense, you can also pull out of that. A push query is where that's the stream in, stream out thing. So you've told the KSQLDB server, please just stream me results as you have them, push them to me, and I'll take them. So we would be in this analysis thinking about pull queries as the thing that we would want. Yeah, already said that. Okay, what's next? The cloud data warehouses. And that's the great thing about generative AI, is where else am I going to get, with my budget, a picture that looks like Caravaggio, like some Italian Renaissance painter, that looks like a bunch of scrolls on the wall in the clouds? I mean, you're never going to have that any other way. There you are. There are a few of these I want to talk about, just kind of mention them. We've got BigQuery, Amazon Redshift, Snowflake, Azure Synapse. Apparently, cloud data warehouses are blue. That's what we can take home from this. There's very common, I don't know, clouds are in the sky is blue. I'm not sure what's going on there. I don't know if the branding teams constantly hire from each other, or they meet in secret. There could be some kind of antitrust violation going on here. I don't know how deep the rot goes. But yes, blue is the color that we can have there. And the differences between these absolutely do not matter for our purposes here. Just consider them the same thing. You commit to your cloud provider's cloud data warehouse, or there's Snowflake, which is neutral, and you put your data in there, right? That's really the thing. These are the cloud-based heirs of legacy data warehousing. The thing that we used to do starting in the 90s, this is, we sort of went to Hadoop and realized that didn't work very well, kind of rounding off all the rough edges. This is what we're left with these days. So these all ingest from batch and streaming sources, but they tend to be sort of shaped around batch data. All right, they're all kind of adding streaming ingest, but the assumption is there's a big pile of data and you want to put it in the data warehouse. They are also going to tend to need you to define schemas, tables. You put your data into something that has structure, and access to that data is going to have latency characteristics that kind of feel more batch than real time. So typically, cloud data warehouse queries over practically sized data sets with practical, interesting queries, latencies are going to be in the tens of seconds or maybe minutes for bad cases. And that's fine if you're powering a dashboard, right? If that's what you're doing, then that sort of latency is going to be just fine. And this really is clearly an analytical only way of querying a stream. You dump your stream into the data warehouse, and now you can build dashboards on top of that, or sort of a data science team can do batch operations that are analysis of this, that, and the other. But this doesn't face a user directly. You wouldn't have a feature in an application that goes and queries Snowflake because I enter something and I tap, and now the query happens and I'm sitting here waiting for it and it comes back. That's not going to work. So if it's a dashboard that has to update every minute or 5 minutes or something, it's great. And there are a lot of those dashboards in the world, so there's a lot of these being used. So yes, you can pipe your Kafka topic into the cloud data warehouse and create a table and read things, as long as all of this glorious real-time event-driven world over here can kind of slow down and turn into a batch world over here. I think there is a growing sense that seems weird. And if it works and it's what you need and no latency, no SLAs are violated, it doesn't matter if it seems weird. It's what you should do, right? But increasingly, people are like, oh no, this all has to be instant and real time, and everything's available to the user, and everything updates right away because everybody's got a phone in their pocket, and that's just how life works. And you're like, you slow down into cloud data warehouse land. So there are some kinds of use cases that just don't fit here, and you have to look for that. Very similar to cloud data warehouses are the heir of Hadoop, the data lake. So here we have these data engineers and data scientists carefully analyzing these scrolls in the data lake. You all know what this is, right? We've got databases, we extract data from the databases, we've got Kafka, we've got whatever there is in the world, put it into the data lake and figure it out later. That was kind of the selling point of this initially, right? The selling point was, man, data warehouses are so hard because you extract and you transform and you load, and you have to do all that thinking about schema, and it's brittle, and it's so hard to figure out what the schema is, and then you have to migrate, and it's terrible. How about you just extract and load it into the data warehouse, put it there, and figure it out later? Some people's backpacks are like this, right? It's schema on read. You just gotta throw crap in there, and then I need a pen. Well, I don't know. I'll just go look for things. And hey, maybe that works for you, right? It's easy to put stuff into the backpack. That might be okay. And it's not like data lakes are some kind of a broken thing. They're here to stay. But let's kind of think about how they work. This began life as the HDFS cluster at the center of Hadoop. Nobody really builds new HDFS clusters anymore. People started to use S3 and just put things in there, and that didn't really necessarily solve things because of this ELT versus ETL thing that was the selling point of the data lake. The we'll figure it out later doesn't seem like it really was good. It turns out that the structure of this stuff matters. Now, the cloud data warehouses, they're upfront with you. They're like, no, it's a table, there's columns, do it, figure it out, make it work. And data lakes are like, nah, it's fine. This is a file. You just write something, read the file later. I don't know. There's data engineer will do that. And that we're seeing this migration in this space to really this competing triad of technologies, Iceberg, Hudi, and Delta Lake, of which it very much seems like Iceberg is emerging as the winner, that are ways of solving that structure problem in the data lake, of imposing a tabular view on semi-structured data. So we tried to, this happens. Try to get away from SQL, SQL comes back. You say, I don't need tables, tables come back. You mean it's all tables? Yeah, always has been. In data lakes, a few characteristics here. There's a radical decoupling of storage and compute. So storage is S3 probably, or Cloud Blob Store of your choice. And that's very cheap. You don't have to care about replication. Vendor does that for you. Everything's great. Write, read, fast, wonderful. You don't have to worry about it. And you've got some other kind of machine somewhere else that you issue a query to, and it goes and figures out where the right stuff is and moves it around. So with that decoupling, you get a lot of flexibility. You get to have very cheap storage. You can scale compute up and down in nice ways. You pay for that in latency. These will never go very fast because of that decoupling. Structure is a little less important, but as we're seeing, it still, it's still rearing its head. And yeah, reads, as I said, reads are generally slow, and streaming is historically difficult, but supported. Okay. Now, we'll talk about the last category, which is real-time analytics databases. This is not a brand new category. You've got players like ClickHouse, Druid, Apache Pinot. They've been around for a while. I mean, Pinot is 10. He's drinking a glass of Pinot because that's the technology I work with, and what I'll be talking about briefly here. But the idea is you don't want to just serve a dashboard. Okay, that's a solved problem. We've got the data lake, got the data warehouse. There's like lots of ways to do that. Inventing a new database is a terrible idea, right? If you have a friend, you sit down and they're like, I think I should write a new database. You want to ask questions like, what's going on? Is there a problem at home? Is there, you're estranged from your parents and you're trying to prove yourself. Like, what is that about? Terrible idea. Well, you know, what happened here was we didn't just want to power dashboards, but when Pinot was created at LinkedIn, they wanted to take, this was like in the early days of Kafka, where we've got all this stuff in topics now, and you wanted to take analytical queries and actually power the UI. So you look at the mobile app, or you look at the load the web page on LinkedIn, and synchronously, you go back to this database, do a query, and you get live analytics results back. So it's not just showing a decision maker a dashboard, but it's powering a feature and exposing analytics data to the user. New thing. I mean, it used to be to do that, you'd have to have some batch job, pre-compute things and put it in a key value store or something like that. It's going to be out of date, and that's a terrible life and everything. So now we've got these things that are designed for the high concurrency and low latency of user-facing queries. Historically, key value stores, relational databases in the transactional sense can certainly do this. And now you can with OLAP too with things like Pinot. Ingest from streaming and batch sources definitely aligned towards streaming. I mean, it does both, but it's created, it makes no sense in a world without Kafka. You just wouldn't have it. And in the case of Pinot itself, it evolved right alongside Kafka. And that integration, because it was built sort of down the hall from the folks who are building Kafka, it has what I describe as a very intimate integration with Kafka. It's not time to go over that, but there are videos on YouTube that even have me in them where we talk about this. It just sort of reads at a very low level. You don't have Kafka Connect in between Pinot and Kafka. Like, that's absurd. It just reads directly. And that it just looks like tables, right? There's not much to it. So this is really analytics, but shaped like real-time data. I said before, if you've got this glorious event-driven reactive microservices world over here, and you're piping it into this sort of batchy data lake or data warehouse where you have to slow down to, it takes a minute to get an answer to anything because you're spinning up jobs and moving across networks and all that kind of stuff, that might feel weird. Well, this doesn't. This feels like it's this part of Kafka that lets you do classical analytical queries of scanning the many things, aggregating, grouping, all that stuff in sometimes crazy fast ways. And the kind of cool insight here is users become decision makers. Analytics is all about showing the state of the business to decision makers. Well, all of our, not all, but so much more of our life is now mediated electronically. We become decision makers integrated into the loop of what the application is doing. And so finding ways to expose that data at the user interaction level is kind of what Pinot is all about. All right, need to go to Q&A, but I just want to give you a few thoughts on technology selection, kind of in conclusion. That's what this talk is about, okay? We have this problem where application architecture is suddenly very different, and we don't quite know how to do it. And we have to pick tools from among many where the choices aren't as clear as they used to be. They will be in 5 years, 10 years. Maybe we'll all have moved on to management. Maybe we won't, I don't know. But this is going to be easier for kids who are 10 now and are learning to do this in 10 or 15 years. It's hard for us now, and we're doing technology selection. So sometimes you just go with what you know. We talked about Kafka Connect. It gives you a relational database. Are there some downsides? Yeah, but that's a great upside. Go with what you know. That's not bad to do. That can be a good decision. Sometimes you really care about performance. Sometimes you don't, and you need to have the maturity to realize, hey, you know what? A second is okay for me. Tim told me a star tree index would do 10 millisecond queries on petabyte data sets in Pinot, and that sounds cool, and I can brag to my friends, but if you don't need that, stop, right? When you do need it, get it. Community matters, okay? We're clearly in a space here where there are more solutions than there going to be eventually. There's going to be some, what we politely call consolidation. I mean, some things will die out, some things will win, and You have to look to how robust is the community around a technology. Who else is using it? Who cares about it? Are people investing? Can you find people to hire who know how to do it? Can you get help when you have questions? And this is where we are right now, as I see the world. You've got at the top, there's always the code that we wrote. That's the code that actually does stuff for our users, differentiated application code. At the bottom these days is Kafka, right? Our data, there we are. Our data is increasingly in these logs in Kafka. That's what I do, that's what I write, that's what serves customers. Here's where my data is. In here, we're exploring in this area where there are dragons in the water and we really don't know what's going on. You are a part of that exploration right now, and that's what this is about. We're trying to make wise choices about how to query streams. All right. I should, before we go to Q&A, Startree has an event. It's in 2 weeks, and it's in San Jose. I happen to know that that's far away because I live 20 minutes from there, and it's the jet lag will get you. So anyway, even if you can't be there, rtasummit.com, you can get links to videos after the fact. And if you want to learn more about Pinot, you can go to dev.startree.ai, where we have things there. So thanks for being here, everybody.